Good morning, students. In second year, out of 16 units, there are 5 units completed. 2 are from physical chemistry, surface chemistry and chemical kinetics, and 2 are from organic chemistry, and 1 is inorganic, that is general principles and isolation of elements. Then today I'll start and I'll take another important inorganic chemistry, that is P block elements, second PUC concept. In first year also, there are some P block, elements are there in first year, that is for 11th standard, first PUC. There are 13th group, 14th group, 13 and 14 groups. That's why there in first PUC heading is some P block elements. Now in second year, 12th standard, continuity P block elements, remaining P block elements. They are 15th group, 16th group, 17th group and 18th group. These are the 4 important groups in second PUC or 12th standard. So anyhow, from blocks, in first year about S block, alkali and alkaline earth metals completed successfully. Here alkali metals are here generally hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. First group this is. Alkaline earth metals, second group, this is beryllium, magnesium, calcium, strontium, barium and radium. This is. So in first year, under the name of S block elements, blocks completed. S block completed. And in second year, P block concept is there, but in P block already in first year, are 13th group, that is boron family, boron, aluminium, gallium, indium and thallium, 13th group boron family, and 14th group carbon family, carbon, silicon, germanium, tin and lead, Pb. Greek letters, plumbum, stannous. So in first PUC, that is in 11th standard, yeah, the 2 groups P block elements. So heading is in 11th standard, some P block elements, 2 groups. Then here in P block elements in second year, remaining groups are 4 are there, 15th group this is, 16th, 17th and 18th groups. This is nitrogen family, nitrogen, phosphorus, arsenic, antimony, stibnite, Sb and bismuth, Bi. Now this is 16th oxygen family, oxygen, sulfur, selenium, tellurium and polonium. This is fluorine, 17th group, that is fluorine, chlorine, bromine, iodine and astatine. 18th group elements, that is 0 group elements, that is helium, neon, argon, krypton, xenon and radon. This is the story of P block elements. So it is a S block, it is a P block concept, P block, and it is a D block, the D block contain total here 10 groups. It is a F block, lanthanoids and actinides. So in first year, 11th standard for you, under the name of periodic table, periodic classification of elements, complete this periodic table explained in first PUC in 11th standard. Now on the basis of this periodic table, again separately created S block elements one chapter and some P block elements one chapter in 11th standard, and remaining P block elements in second PUC 12th standard. Then after P block elements in second year, there are another important unit that is D and F block elements. After this P block, one more important concept is there. That's why for any objective, for any competitive examination, better you concentrate on this periodic table, better you read every day all these elements, position, atomic numbers and electronic configuration and valency. So we know the periodic table first year, complete analysis of the periodic table and groups either in first and second PUC, 11th and 12th standard, based guarantee and objective they'll give for a neat minimum 4 to 5 marks. They are related with the periodic table and blocks. And in KCET compulsory, they'll ask 4 to 5 questions, periodic table, blocks, D and F like. And in JE also they'll ask in advance. That's why for inorganic part, this is a very, very important table. In chemistry, every chemistry student compulsory should aware about this table, periodic table. Okay. Now, right now, here S block elements successfully completed under the name of alkali and alkali metals, alkaline earth metals. In first year, 11th standard, while explaining the blocks, each and every one element story explained. Story means biodata of the lithium, sodium, potassium, rubidium, cesium, francium. Biodata is nothing but in chemistry in terms of physical and chemical properties and their biological activities and their compounds, existence, availability of these compounds in atmospheric air in earth crust. So here in alkaline earth metals also same thing. Now in P block elements also, here in first year, boron family, 13th group explained. So it is started with boron element, that's why it is called a boron family. 5 elements are there: boron, aluminum, gallium, indium, thallium. Now in this boron family, boron compounds and aluminum compounds explained in first year. Then carbon, one of the most important element in 11th standard explained about carbon family. Elements are carbon, silicon, germanium, tin and lead. Now the story about P block elements in second PUC, that is 12th standard. So on the basis of first year concepts, on the basis of first year knowledge, 11th standard knowledge, here in second PUC, 12th standard, introduce 4 important groups. First we'll discuss about the PUC. So in PUC, once we can observe the question paper, with me there is one question paper, previous year question paper. So here in this previous year question paper, once we can observe in this P block element second PUC, highest weightage chapter it is, 10 marks weightage chapter it is. But here from P block elements, don't expect any big question, 3 marks direct, just like in other subjects. Only they'll create one word answers. P block elements complete based on one word answers only. There is no other big questions, but heading they'll get 3 marks. In that 3 marks they'll ask A, B, C like. That's why better you concentrate only 1 mark and 2 marks only. To get the 1 mark and 2 marks for objective as well as PUC, better you read line to line textbook NCERT enough. So according to this PU board, Karnataka PU board pattern, here from 18th group, here only 1 question, that is 1 mark, that is in PU examination, question number is 6. This is the question number 6, only 1 mark. Now here 15th group only 1 question, that is question number yeah, only one question, that is 3 marks, that is question number 20 in public PU board. This is the question number, your question number 20 in PU board examination. Your marks 3 marks, number of questions. Number of questions only one question. That is from 15th group, only 3 marks. 3 marks, they won't ask direct 3 marks. Some case they'll give ABC model. Or direct question also maybe they'll ask from 15th group. But 16, 17 onwards, there is no direct 3 marks, only ABC model. That is here one question, 3 marks. That is question number 21. Now here the question number 17, here 17th group question number 1 only. Here also 3 marks, only one question. Here question number 22 in PU board examination. Here question number 6. 3 plus 3 plus 3, 9 plus 1, total 10 marks. So in this P block, in second year, 4 groups are there, 15, 16, 17, 18 groups are there. Those who are expecting out of out in PUC, 70 by 70. 70 by 70 in theory. We want 70 by 70. And practicals 30 by 30. So the 100 by 100 in PUC to get 100 by 100 marks. Compulsory to get the 70 by 70, compulsory read these 18th group elements. Because this 18th group element question number is 6, only 1 mark, that is in part A. In part A, question number 1 to 10 questions are there. In this 1 to 10 questions, there is no choice 1 to 10. In that 1 to 10 questions, to get the out of out, question number 6, that is 18th group. That's why to get the out of out in PUC or 11th standard in this according to PU board, compulsory read these 18th group elements. One question guarantee. That one question is inserted in part A. In part A, there is no choice. That's why compulsory read this 18th group. Very simple question they'll ask from 18th group based on basics. Just in NCERT, 3 to 4 pages material is there. Better read line to line, 3 to 4 pages. Compulsory will get 1 mark. Year will get guarantee 1 question. Then from 15, 16, 17, these 3 units, from each unit, from each group, only 3 marks. Once read 15th group thoroughly, all concepts, all side headings, all important properties. Introduction, general introduction of physical and chemical properties, better you read thoroughly 15th group, then automatically 16 and 17 similar, just by changing their elements. Only elements and their properties, slight variation is there, remaining everything is same. That's why 15th group read thoroughly and slowly, line to line from textbook, and I'll explain clearly line to line every point. Better you read as a newspaper, line to line, underline, and read wherever or whenever important, underline and read and note down the important point from textbook. I'll send through the WhatsApp one material, that is inside textbook material as well as college material. Follow that. Clear? Now I'll start this 15th group elements right now. Now in this 15th group elements, so once we can observe here in this long form of the periodic table, this is second year concepts. These are the 4 important groups are there. In these 4 important groups, today I'll take about 15th group. This is 15th group. This 15th group elements, also called nitrogen family. This nitrogen family, also called Nitrogen family also called nicogens. P is silent. P-N-I-C-O-G-E-N, nicogens. So are this 15th group are nitrogen family, or these are also called a nicogens. Yeah, nitrogen, phosphorus, arsenic, antimony, and bismuth, Ba, collectively called nicogens. Why these are called nicogens? These are generally creates a suffocation or the suffocating compounds, and their compounds are called nictides or nictides is silent, because these compounds create suffocation, and it creates some pressure. Now, this nitrogen, phosphorus, arsenic, antimony, bismuth family members, nitrogen family members are called nicogens. Generally, here, according to the general electronic configuration based on periodic table, based on their rules and regulations, your first point is introduction in this first point is general electronic configuration. This is general electronic configuration. Your for complete P block, general electronic configuration is rare gas, or noble gas, inert gas. Your NS2 and NP126 is the general electronic configuration of complete P block. Now, based on this, if we can write the same thing, rare gas, RG rare gas, your NS2 already completed NP1, it is 13th group. If it is rare gas, your NS2, NP2, your same thing, your NS2, NP3, your NS2, NP4, your NS2, NP5, your NS2, NP6. So once we can observe their general electronic configuration, here NS2, NP1 to 6 is there. That is P block start with this boron. Boron atomic number is 5. Electronic configuration is 1s2, 2s2, 2p1. This is the inner orbit. This is rare gas, that is helium. Your n value is 2, that's why ns2, np1 this is. So here the first member of the P block element entered into the P block, that is boron, entered into the P subshell of this second main energy level. So here the S orbital is completely filled already in S block element. A newly entered electron enters into a new main subshell, that is a P subshell. That's why it is called a P block element. Boron, carbon, nitrogen, oxygen, fluorine, neon are some P block elements. Starting members of this group: boron, carbon, nitrogen, oxygen, fluorine, neon. Now here boron is the first member of P block element. Last entered electron enters into the P subshell. That's what is a P block. P onwards, last entered electron enters into a P subshell. One electron increases. In carbon family, here are 2 electrons. Nitrogen family 3, 4, 5, 6. That's why it is 13th group, 14th group. 15, 16, 17 and 18th group elements are there here. So in first PUC, 11th standard, 13, 14 completed. Yeah, 15 onwards we want. That's why in 15th group elements, on the basis of their general electronic configuration, your general electronic configuration of 15th group elements is nitrogen family is NS2NP3. That is the general electronic configuration of 15th group elements. Now here the last entered electron also entered into a p subshell. That's where the electrons 1 to 6 increases. That's why here NS already completely paired. That's why don't write NS2. Your general electronic configuration of p block elements, don't write NS2, NP6. That is wrong. That is only 18th group elements only. But for p block elements, its general electronic configuration is NS2, completely paired it is. 1 to 6 electrons are increasing. That's why 1 to 6 electron. That is for complete p block elements, general electronic configuration. And for 15th group is NS2, NP3. That is the first important electronic configuration. So anyhow, on the basis of their electronic configuration, here I will write these 5 elements electronic configuration. General electronic configuration of these 15th group elements. Element is nitrogen. Atomic number is 7. Electronic configuration is helium. Your 2s2 and 2p1, sorry, 2p3 is the general electronic configuration of nitrogen, first number. Atomic number is 7. And its electronic configuration, we can take helium, 2s2, 2p3. For this helium, we can write 1s2. Instead of this helium, we can write a rare gas. This the atomic number is 7. This the element and symbol is nitrogen. Now here nitrogen electronic configuration, once we can observe here, box method we can write here your helium and your 2s2 is completely paired and your 2p3 is according to Hund's rule. P subshell containing 3 degenerated orbital, each degenerated orbital that is px, py and pz filled with 1 electron according to Hund's rule or Hund's rule. According to this rule, each degenerated orbital is filled with a single electron. The extra remaining electrons are present, they are paired up. That's why it is completely filled it is. It is off filled. According to that rule, Hund's rule, off filled or completely filled orbitals are more stable. Yes, is it correct? Off filled or completely filled orbitals are more stable. That's why this 15th group element shows some peculiar properties than compared to the 14th and 16th group elements. Now, once we can observe in this nitrogen, here after 2s and 2p, there is no 2d orbitals. There is no 2d orbitals means here after second main energy level, in this second main energy level, according to Euler's diagram, here it is 1s, here it is 2s and 2p, here 3s, 3p, 3d. Now here the 4s, 4p, 4d, 4f. Here the 5s, 5p, 5d, 5f and so on. This is the Euler's diagram. Once we can observe in 1s, here it is 2s, 2p, 3s, 3p, 4s, then 3d, 4p, 5s and so on. In second main energy level, there is no 2d and there is no 2f. These are not present. And in third main energy level, after 3d, there is no 3f. That D start with the third main energy level, F start with the fourth main energy level. That's why in nitrogen family, not only nitrogen family, any carbon, nitrogen, oxygen, fluorine or boron family, this is the complete second period. All second period elements do not contain any D subshell, only S and P subshells only. That's why here nitrogen electronic configuration, according to this, there is no d orbital. This is a very important point. Based on this, we can expect one question, that is anomalous properties of nitrogen compared with the same family members. Regularly in PU level or theory level, subjective level, here either carbon, nitrogen, oxygen, fluorine are these zero group elements. In each and every one family, one question we can observe, that is anomalous properties of nitrogen, anomalous properties of oxygen, anomalous properties of fluorine, are these groups are anomalous properties of carbon and boron. Anomalous means peculiar properties. Yeah, the nitrogen, phosphorus, arsenic, antimony, bismuth, all are the same family members. But this nitrogen shows some peculiar different properties than phosphorus, arsenic, antimony and bismuth. That's why nitrogen has some important anomalous peculiar properties. Similarly, in further groups, oxygen also shows some anomalous properties. And fluorine also shows some anomalous properties. Among these three, in PU we can expect one question. Write any two anomalous properties of nitrogen, oxygen, or fluorine. Or why nitrogen shows anomalous properties? Or oxygen shows anomalous properties? Or fluorine shows anomalous properties? Why give reason? For all common. For all the three questions, common statements. So once we can observe this nitrogen, in further 16th group and 17th also same explanation. Just they'll give the simple guidelines there, but here clear information I am giving, just observe it. Yeah, nitrogen, why shows anomalous properties compared with phosphorus, or arsenic, or antimony, or bismuth? Why shows peculiar properties? Because here in nitrogen, absence of d orbitals, its covalency cannot exceeds its number of valency electrons. Maximum covalency is 4 only. And absence of d orbital and its a small size and high electronegativity, nitrogen shows some anomalous peculiar properties. So here nitrogen shows anomalous properties. Main reason is absence of d orbital. Do not form any p pi and d pi bonds. There is no p pi and d pi bonds. Nitrogen do not form any p pi and d pi bonds. Just observe here. In chemical bonding, explain to you nitrogen N2. That is N triple bond N is there. Here one is sigma. Remaining two are the pi bonds. Between nitrogen, in its outermost orbit, only p orbitals are present. There is no d orbital. That's why nitrogen, this p bond is pi bond is p pi and p pi only. One, and one more is p pi and p pi only. There is no d pi and p pi bond. Why? There is no d orbital. 2d is not present in that nitrogen atom in its outermost orbit. That's why it cannot excite, only up to p only, 2p only. That's why it do not forms p pi and d pi. It forms only two bonds, pi bonds. There are p pi and p pi bonds only. Whereas in case of this phosphorus, yeah, to this nitrogen, to get the phosphorus atomic number is 15. Its number just add 8. 8 plus 7, 15. Now the 15 add to this 18. How much? Arsenic atomic number 32. And to this 32 again add, 33. Now again to this 33 add 18, we'll get a SB, that is how much atomic number? 15. 1. Now to this add here 32, then we'll get 83. So atomic numbers, easy to remember, easy to write its atomic numbers. That is generally for first period, like 8, 8, 18, 18, 32. For this second period onwards, that's why 8, 18, 18, 32. To the nitrogen, to this add 8, just will get 15, to this 15, 33, 18, 51, again 32, 83. These are the atomic numbers of nitrogen, phosphorus, arsenic, antimony, and bismuth. Here 15, before 15, 10 we know that is neon, atomic number 10. And here the top to bottom atomic number increase, newly added electron enters into a new main energy level. So are the 2 to 3, that is 3s2 and 3p3. But D start from third main energy level. That's why here the electrons maybe in excited state entered into the 3D main energy level. But the possibility of d orbital is not present in nitrogen. Only absence of d orbital and here phosphorus onwards, p orbitals, phosphorus onwards, d orbitals are available because third energy level onwards d subshell started. That's why in case in excited state electrons are excited from p subshell to a d subshell, then it forms like p pi and d pi bonds. When it forms pi bonds between phosphorus and some other important elements. Now similarly, here 10 plus 2, 12 plus 3, 15. Similarly, here 33, helium, neon, and it is argon. Here 18. Remaining here 18 means if you write 4s2 and 4p3, won't get correct electronic configuration. See here 18 plus 2, 20, 20 plus 3, 23. But we want how many? 33. That's why electron after filling completely this 3D orbital. That's why we can write for our convenience 3D10, 4s2 and 4p3 is the electronic configuration. Now see here 18 plus 10, 28, like 28, 30, 33 balanced. Now similarly, here in this case, here nitrogen, phosphorus, arsenic, antimony, atomic number is 51. Here helium, neon, argon, we can write krypton, it is 36. Here we can write 4d10, 46. Now here the 5s2 and 5p3 balanced 51. Now here 83 to get 83, helium, neon, argon, krypton, it is xenon. Now it is 54. Now here the 4f14, here 5d10, and here the 6s2 and 6p3 is the electronic configuration of bismuth. So once we can observe here, all these are the noble gases, rare gases, helium, neon, argon, krypton, xenon. And here the outermost orbit number is here 2 to 3. What happens here? Increases 2 to 3. Now here n value is n is equals to 2, here 3, here 4, here 5, here the 6. That's why nitrogen is a second period, phosphorus is a third period, arsenic is a fourth period, fifth period, sixth period, seventh period is here last. Now this the n value is 2. Your electronic configuration is by using this NS2. NP1 is for 13th group elements, 2 is 14th group elements, now 3 is 15th group elements. That's why the NS2 NP3 is the general electronic configuration of 15th group elements. Based on this 15th group elements general electronic configuration, are the 2s2, 2p3, there is no 2d orbital. That's why your nitrogen shows some anomalous peculiar properties compared with the other members. Like phosphorus, 3d is there, and arsenic, 3d is there. Here 4d also exists. Now here the 4f also. Now in stibnite here 4d and 5f exist. Now bismuth here 4f, 5d. Means all subshells sp d orbitals are available. Now here the top to bottom new main energy levels increases. That's why imagine general, this is size, maybe top to bottom what happens, observe similarly number of new main energy levels increase, size what happens, increases. Observe here. No need to consider the number of 7 energy levels, only for understanding purpose. By using this electronic configuration, by using physical observation, your orbits, your top to bottom size increases. On the basis, I'll clarify, complete some important physical properties of 15th group elements, nitrogen, phosphorus, arsenic, and antimony, bismuth. Anyhow, after this general electronic configuration, one simple important point, occurrence of these 15th group elements. After that occurrence, we'll start physical properties. Clear? Electronic configuration. Now here, on the basis of this electronic configuration, I'll explain some important physical properties. Generally in atmospheric air, along with oxygen, some important dissolved gases are present. Now, particularly under this 15th group elements occurrence, about first point is about nitrogen. Now, here in atmospheric air under normal conditions, here it is available, the 78% by its volume in atmospheric air, and here 80% by its mass. Means only these are in atmospheric air, not in earth crust. But in earth crust, the availability of these elements, phosphorus is more than nitrogen, than arsenic, than antimony and bismuth. This is the occurrence of the 15th group elements in earth crust. Phosphorus is more. But in atmospheric air, nitrogen is present by its volume is 78 and its by mass is 80% is present. And mainly your nitrogen is present in a living system as a biology student. In a living system here amino acids are there. 20 amino acids. One is newly discovered 21 now, but in our textbook only 20 are there. Amino acid, these are called in chemistry alpha amino acids. These alpha amino acids, general formula is R bond NH bond like here the CH bond NH2 bond COOH. This is. So the general formula of amino acids, in these amino acids here amino group is there and here carboxylic group is there at the alpha position. That's why it is a alpha amino acids. Your R value, alkyl group changes, 20 amino acids will get it. Main here glycine alpha amino acid, main important for a living system. Right now in papers and journals about COVID-19, they are discussing about this glycine alpha amino acid. Main that virus attacks reduce the production of glycine in the living system. That's why body immunity system decreases. That's why here the alpha amino acids, amino and carboxylic group, nitrogen is present. That's why the main important source of amino acids, main element present in that, along with carboxylic, carbon, oxygen and hydrogen, nitrogen also present. So are the amino acids and amino acids combines with different combinations, will get more than 10,000 molecular mass, will get proteins. Proteins are the combination of alpha amino acids only. So are the in plants and animals in living system, nitrogen is present mainly under the name of amino acids and proteins. Clear? In atmospheric air, availability is that in living system and plants. And in earth crust, mainly nitrogen is present as nitrates. The nitrogen N2 in earth crust. In earth crust exist as nitrates. Maybe in objective level they will ask. Yeah, KNO3 is there. Its general chemical name we know. What is that? Potassium nitrate. So its name is potassium nitrate. Common chemical name it is, but its availability according to common system, it is uh, peter, generally saltpeter. It is called Indian saltpeter. It is Indian saltpeter. This is. Now NaNO3, sodium nitrate. This is sodium nitrate. This is Chile saltpeter. Chile saltpeter. These are the two important nitrates available in earth crust. Maybe based on this, they'll ask some objective. In objective, they'll create which of the following is Indian saltpeter or Chile saltpeter like, or in earth crust nitrogen is exist as nitrates or nitrites like sulfates or carbonates like, they'll create some important questions. Okay, the next one is already given to you. In earth crust, phosphorus percentage is more, extinction percentage of availability or percentage of minerals under the name of minerals, phosphorus availability, phosphoproteins and phosphorite rocks minerals available. So are the phosphorus availability, that is apatite family is there. Very important concept formula this. Now here the phosphorus, that is phosphorite rock. This is mineral under the name of mineral, that is apatite. Apatite family. That apatite family formula is Ca9, PO4 taken 6, here the 3 CaX. Here this also we can write 3 Ca3 in some other material they will create, right? 3 Ca3, here the PO4 taken twice, now here the CaX. Now your X is fluorine, chlorine or OH. Instead of this X value, if we can take fluorine, just to change, fluoroapatite. If you can take X value here, the Cl, chloroapatite. If you can take X value, OH group, hydroxyapatite. So which of the following is a fluoroapatite, chloroapatite, hydroxyapatite? Combinations, chemical formulas important. For example, here are the Ca3PO4 taken twice. Now here the Ca calcium valence is +2 oxidation state, but fluorine -1 by crisscross method. Plus and F -1 by crisscross method formula, its formula is CaF2. That's why here, sorry, CaX2 this is. Now its formula is CaEF2. So its name is fluoroapatite. Fluoroapatite. And similarly, if you can take same thing, CaCO 3 PO4 taken twice, CaCl2 chloroapatite. Here the 3 PO4 taken twice, CaOH taken twice, hydroxyapatite. It is chloro, it is hydroxyapatite. Generally, this phosphorus is present under the name of phosphoprotein in animals and in milk and egg proteins. Generally, in biology students, in biology, egg protein, milk proteins are there. In protein, phosphorite linkage are present under the name of phosphoprotein available, all these phosphorus. Clear? The occurrence of nitrogen, phosphorus, then remaining elements of 15th group elements, arsenic, stibnite and bismuth are generally available under the name of minerals in earth crust. under the name of sulfide ores. In metallurgy, already explained, in isolation of elements, general process and isolation of elements, about minerals, ores, gang, matrix, very clearly explained SARS about minerals, ores. These are all the three are available under the name of as sulfide ores. But if concentrate these important minerals are the ores, collect from each and every one unit, either from metallurgy or some P block elements or any groups. In objective, they'll create some important questions. Which of the following is a sulfide ore or oxide ore? Generally, they'll create on the basis of common names, popular commercial names. Zinc blend, not a zinc sulfide. Zinc-site, wolframite, like iron pyrites, like zinc carbonate, calamine, like different name source already given. Same as here AS2S3, here SB2S3, and Bi2S3 are the some important sulfide ores already in colloids explained. Arsenious sulfide colloid, negatively charged colloid. To produce the charges, positively and negatively charged colloids created there As2S3, Sb2S3, some metallic colloids, metallic sulfide colloids. These are the some important minerals, sulfide minerals of remaining three elements. Clear? About 15th group elements introduction and some important general electronic configuration and some important points about occurrence of these 15th group elements. Now, some important properties. 15th group elements are physical properties. Physical properties of 15th group elements. Generally, first one is physical state. So in a physical state, generally at a room temperature, your nitrogen N2 is a gas at room temperature. Phosphorus is also a solid, but it is easily evaporated, easily vaporizes. Remaining arsenic, antimony and bismuth are these are solids. Now here gaseous state, it is in gaseous state at room temperature, generally under normal conditions. By changing their conditions, maybe we can condense into a liquid by freezing. That's why here physical properties under normal condition, gas, solid, easily evaporated, and these are solids only. Generally, once we can observe in this physical state, its characteristic is metallic character as well as non-metallic character. Metallic and non-metallic character. Generally, top to bottom in periodic table, first PUC, 11th standard, top to bottom metallic character increases, non-metallic character decreases. All these are first year, first PU, 11th standard, periodic table points only, all these. So metals means here top to bottom in periodic table. Here the top to bottom nitrogen to bismuth. Here the Ni, nitrogen to bismuth, here metallic character, what happens? Increases. But here non-metallic character, nitrogen to bismuth, here decreases, non-metallic character. So in 11th standard in periodic table, when our metallic character increases, what happens? Electropositive character increases, electronegativity character decreases. That's why here these are generally non-metal, that non-metal to slowly non-metallic character increase, metallic character increases. It is non-metal. It is also a non-metal. These are metalloids. It is purely metal. Now these two are the non-metals, and these two are the metalloids. metalloids, and bismuth is a typical metallities. Okay, that's why metallic character nitrogen to bismuth increase because it is a pure metal, but non-metallic character nitrogen to bismuth decreases. So on the basis of these, metallic character increase means what happens? Electropositive character increases top to bottom. Electronegativity character decrease. See, observe here in the long form of the periodic table, among all known elements, highest. So the highest electronegativity element is fluorine. That's why in the long form of the periodic table, left to right, what happens? Electronegativity increases. Highest electronegativity character increases. Top to bottom electronegativity character decrease. Similarly, common general important point is here electronegativity and electropositive character and ionization potential. Before that, next important point is atomic radius. We know already in 11th standard radius, types of radiuses, covalent radius, van der Waals radius, ionic radius. On the basis of ionic radius, in periodic table, compulsory one concept, very, very important, that is isoelectronic species. Based on isoelectronic species, we will get guarantee one question, which of the following species is the largest size, smallest size? For example, here atomic radius, atom is very small. So somewhat difficult to calculate its size, one atom size. Distance between the center of the nucleus and its electron cloud up to electron cloud influences in any atom of an element. It is very too small atom. That's why in molecule we can calculate the covalent radius. So half of the internuclear distance, this is called radius, covalent radius. So that covalent radius are the nitrogen to the phosphorus, phosphorus to the arsenic, arsenic to the Sb, Sb to Bi. What happens? Size what happens? Increases. Covalent radius increases because when our atomic number increases, top to bottom, 7 to 15, 33 and here 53 and total 80, 51 and 83. So top to bottom atomic number increase, newly added electron enters into a new main energy level. That's why the covalent radius top to bottom what happens? Size increases. Year to year size increases from nucleus to the outermost orbit. So whenever top to bottom covalent radius increases, your electrons from top to bottom are loosely bonded from its outermost orbit. A distance increases from nucleus to the outermost orbit. Valence electrons are loosely bonded. That's why size increases. So due to this, your ionization energy or ionization potential both are same, but measure if it is value is expressed in terms of energies, in terms of calories or the joules. That is, we can use as energy, ionization energy by heating. If you can use IP, ionization potential, by sending the potential electrical power, that is volts, electron volts, EV. Definition is same. While using IP, we can use minimum amount of energy is required. But here IP means minimum potential required. Here energy required, potential required. But concept is same. Definition is same. So minimum amount of energy required to remove one electron from its isolated neutral gaseous atom is called ionization energy, common. To remove one electron, we want one energy. If you want to remove 2 electrons, IE2. If you want to remove 3 electrons, IE3, and so on. And number of electrons, that is IEN. When a number of electrons are removed from its outermost orbit, size decreases. Effective nuclear charge increases on its outermost orbit. That's why your effective nuclear charge whenever increase, more difficult to remove the electrons from its outermost orbit, more amount of energy required here. That's why top to bottom here size increases, electrons are easily removed from its outermost orbit. That's why your Ni to bismuth, Bi, its covalent radius, Cr covalent radius increases, but your IE ionization energy decreases. So less amount of energy needed to remove the electrons from its outermost orbit. Okay. So whenever one electron is removed from its outermost orbit, it becomes ion like N plus. Your N plus 2, N plus 3. Nitrogen shows variable oxidation state. I will explain tomorrow in next further classes. Nitrogen exhibit variable oxidation state. Whenever electrons removed from its outermost orbit, size decreases. But in ionic radius, generally top to bottom ionic radius also increases, but its ionization energy is not properly decreases. So the ionization energy, nitrogen to phosphorus, at ionic radius nitrogen to phosphorus, here decreases, again here decreases, again increases. SB and Bi, its ionic radius increases, somewhat slightly variate in their ionic radius. That is due to the inert pair effect. What is the inert pair effect? I'll continue tomorrow in next further class. I'll explain that inert pair effect. And ionization means electronegativity and electropositive characters. Then after that variable oxidation states. I'll cover in next further section. Okay, read well.